Hello guys, my name is Devin, my YouTube channel is DRG Bros, and we're going to be doing sine and cosine power series. Okay, now this kind of adds on to what I was doing in my last video, where I did the power series for e to the x, which is essentially Euler's constant to the x power. But we're going to do something different. So first, I want to do some quick things as kind of background information, just to help you guys remember. So first, we didn't cover this in the last video, but if you watched my video on maps that we already have, you know that a map is an input-output set of numbers that can be written as a table, and a function is a map with one input for every output, okay? But we can use this to give things like a certain thing. So, for example, if we could use this to find out how many days, like for the date 6/13/21 could equal 164, and that could be the number of days since the start of a year, for instance. We could also do something else, like this could be useful for colors, maybe. So if we had the color red, color blue, and the color green, and let's say red equals 1, blue equals 2, and green equals 3, we could say then maybe that purple would be like red and blue. It could be like a 3, maybe a 4. Like we could give all sorts of different numbers. And so we can use this. Like if we take a polynomial, factor x, like that, we could find, like, we know that a polynomial could be written like this, x squared plus x plus 1 or something like that. And we could plug in, like, if we use the same function, polynomial, and replace x with, say, 2, we could always figure out how to solve this. And this is kind of how computers work. But you see, because we know that 2 squared is 4, plus 2, which is 2, plus 1, all of which is equal to 7. Easy as that. So, this we covered in the last video that I'm about to show you. We know that if a function has a power series, it's written as f to the x equals c naught x0 plus c sub 1 x to the 1 plus c sub 2 x squared, and so on for infinity, like this. We could basically write this as c to the n equals f to the n 0 divided by n factorial. And if you don't recall, a factorial is all of the numbers like behind it multiplied. So 4 factorial would be 4 times 3 times 2 times 1, which is 21, or 24, sorry. So, now we're going to use this to, I have this written up, I can't really pronounce it, Malctonia, I think is what it is, I don't know, series for the sine and the cosine of x. So, we're going to start with functions. So we have the f of x, we're going to start distributing. So the f of x equals the sine of x in this case, okay, right? So if we do it to the first derivative, it would be the cosine of x. This is a cycle that I'm going to explain. Next, if we do it twice, we have the negative sine of x. Next is the negative cosine of x. And then lastly, for the fourth one, is the sine of x. And recall from my other video that technically you would write the numbers, but for shorter numbers, you can write the tallies, like 1 through 5. So, this is a cycle. So, just to show you what I mean. So, the sine of x turns into the cosine of x, but the cosine of x turns into the negative sine of x, okay? So the sine of x keeps the sign the same and flips. The cosine makes it negative and flips. So the next, it's the cosine. You okay? Okay. Yeah. But so we're going to use our old one, the Cn equals f of n 0 n factorial. We're going to use this to help us find the right power series. So, I'm going to need a new sheet for this. Yeah. So, what we're going to do is we're going to take the sine of x equals the power series of the sine of x. The sine of x equals f to the 0, 0, 0 factorial x to the 0. Then we do it again. Plus f1, 0, 1 factorial x to the first. All right, and this keeps on going. I'm going to do one more, just so you can see the pattern. f2, 0, 2 factorial x squared, and so on. Now, we can start factoring these out to find that it would equal 0x to the 0 over 0 factorial plus 1x to the first over 1 factorial plus 0x squared over 2 factorial plus minus 1 x cubed over 3 factorial plus 0x to the fourth 4 factorial and so on. And you know where we're getting these numbers from? Well, it's part of like the angles and stuff. So, we know that f to the 0 of 0 with the sine, it's the cosine of 0, or sorry, the sine of 0, which is 0. Okay? Next derivative, we have the sine of 0, which is 1. Then we have f2, 0, which was the, this was the minus sine of, no, wait, hold on. I'm losing it here. So this is the cosine of x. This is the cosine here. And then this is the minus sine of x, or of 0, which is 0. And then f3, 0, is the minus cosine of x, or 0, sorry, I keep saying that, 0, which is minus 1. And then we're back to where we started with the sine of 0 equals 0. That's where we're getting these numbers from. And that's how we could use this to find the power series. And for the cosine, we just reverse this, because this would be in reverse order. So what that would mean is that instead of doing it like this, the first one would be the cosine of 0, which is 1. Then it's the negative sine of 0, which is 0. Yeah, which is 0. Then we have the negative cosine of 0, which is minus 1. Then the sine of 0, which is 0. And then finally the cosine of 0, which is 1. And then we can redo that into our equation to find that it would be 1x to the 0 over 0 factorial plus 0x to the x to the first over 1 factorial plus minus 1x squared over 2 factorial plus 0x cubed over 3 factorial plus 1x to the fourth over 4 factorial. And we could use this to find the power series, which I will be doing, I believe, in the next video. Thank you very much for watching, and we'll see you for another video. Bye, guys.